Right, there's still more people. Good afternoon. Hey. Oh, there's one. Okay, there's still a bit of a trickle of people coming in. So pick a seat. Oh, there's more. All right. Hi. So welcome to the ESC180 lecture, one of the many interesting things that happened to you today. If you're in this room, I can confirm that you survived the praxis midterm. Congratulations. About 45 courses in this program, 2 midterms per course, approximately, maybe 1.5. So that's about how many there are left in your degree. But one down though, so that's good. Okay. If you're watching the video, I can also confirm that you survived the praxis midterm because you're watching the video. However, I don't currently know that. Okay. So life goes on though. So we're gonna do while loops. Is there life after praxis? Yes. Okay. So to remind you, while loops. So the way it works is we say while, then there is a condition. So that's something that's going to be true or false, and we're going to check the condition. And then we are going to repeat the block while the condition is true. So we don't know ahead of time how many times the condition is going to repeat. And the simplest thing we can do with a while loop is just do a silly version of a for loop, right? So we can say something, so like for I in range m to n is going to print m and then m plus 1 and so on up until n, not including n. So m plus 1, m plus 2, and so on up until n, this n minus 1. And the way we're going to do it, so I'm just going to repeat, this is from the previous lecture. So I just want to print this. And let's do it in steps. So I'll set I initially to m. And then I'll say while I is smaller than n, increment I by step. But before you do, print I. So this one is going to do m and then m plus step, and then m plus twice step, and so on, up until n not including n. Right? So for example, if I say something like m is equal to 15 and n is equal to 100, and I'll do steps of, let's say, 12, it's going to look something like this. Yeah, so we start with 15 and then we go in steps of 12. We reach up to, but not including n. Here it happened that we stopped at 99. That's just because of how multiples of 12 work. If I change this to something like 17, that would, again, start with 15 and then 32 and so on. And then it goes up to 83, but it cannot go above 83 because 83 plus 17 is already 100, and we're going up to, but not including n. Make sense? Questions about this? So this is the for loop. And then what I'm going to do is just the same thing, but with a while loop. So I'm going to say initially I is going to be m. And then I'm going to print I and increment I by step. So I initially, if n is 15, m is 15, and n is 100, then initially I is going to be 15, and then it's going to be 15 plus 17, and that's going to be 15 plus 17 times 2, and so on. And we know, because we ran the for loop, that the last number is going to be 83, just because that is how the math works out. So when do we stop? We stop when it stops being the case that I is smaller than n. That's the same in English as saying while I smaller than n, but maybe it's a little bit clearer if you write it out like that, right? So keep going, I is 15, keep going, I is smaller than 100. I is 15 plus 17, keep going, that's smaller than 100. Plus 17 times 2, is it smaller than 100? Yes, keep going, and you'll keep going while it's the case that I is smaller than n. So in this case, I is smaller than 100. So the last thing that's going to happen is you're going to print 83. So this 83, and then I will become 100. And at that point, it's not anymore the case that I is smaller than n, because 100 is not smaller than 100. So if I print I over here, it is going to be 100. Because I is a variable like any other variable. So it starts as 15, then it becomes 32, then it becomes 49, and so on. Then it becomes 83, then it becomes 100. It's going to check, is 100 smaller than 100? No. Okay, stop repeating, go to this line. So let's trace this just to make the point again. So I'm saying next. So I is right now 15. Print 15. And now I is 32. So I'll just keep printing until it prints 83 and it becomes interesting. So now I is 83. Now I'm saying 83 plus equals 17. So I is going to become 100. So I'll press next. So I has just become 100. And now it's checking, is I smaller than n? Well, I is 100 and n is 100, so no. So I'll just go to line 22. So I here is still 100, and it'll just print 100. Does that make sense? So in general, what you should prefer to do is something like this. But if you want to transform this kind of for loop into a while loop, then you can do it very easily, right? So this I is this I, and then this m is the value that I has initially. Then you're going up to but not including n. That's the same as saying keep going while I is smaller than n. And then here you're incrementing I by step every time. So that's I plus equals step. So the print here, of course, you could say I want to print I. You could say whatever, I want to print I squared. That's just an optional thing. Yeah.
Essentially, we're just turning a while into a for by adding our own counter variable.
The other way, right? So the for into a while, you can transform like this by saying, here we're assigning I in range m to n, and here we're doing it manually. So we start I as being m, and then we keep incrementing it by step. It's not necessarily the case that you can take any while loop and transform it into a for loop. For one thing, with a while loop here, and we'll see examples later today, the while loop here, you know how many times it's going to run because it's the same as the for loop. But so how many times? Well, approximately n divided by step.
That's what we're making a while behave like a for loop.
Yes, exactly. So we're basically simulating this for loop using a while loop. But a while loop, you don't necessarily know how many times it's going to run ahead of time. With a for loop, you really should know. There are like small exceptions, but with a for loop, like how many times does this run? Well, n of minus m divided by step, approximately, right? So I'm not going to do this in detail, but how many times does it run? Well, approximately n minus m divided by step times. Does that make sense? Because you're starting from m and you're going to n in steps of step. So how many? Well, the range divided by the step that you do each time. Questions about this? Okay. So, all right. So that's your basic while loop. So we mentioned infinite loops briefly on Friday. So an infinite loop is a loop that runs an infinite amount of time. So for example, it might be something like while true praxis midterm. So that's going to print praxis midterm forever, not a reflection of real life, just an example. So Why is it going to print it an infinite number of times? Well, because it's going to keep checking, is the condition true? Well, it's literally true. So that means that it's going to keep repeating this line forever, because it's going to keep checking, is true still true? Yes, true is still true. And no matter the haste that's induced by the praxis midterm, true is still true. So you print praxis midterm. Equally, while 5 is greater than 4 is also an infinite loop, because 5 just keeps being greater than 4. Does that make sense? There are examples of infinite loops where it might not be obvious by just looking at them that they're infinite loops. Here's an example. So that uses the function is prime that we've written before. This says keep repeating print n plus equals 1 while this whole thing is true. So what does this thing say in English? Anyone? That says it's not the case that n is both even and this is not actually an infinite loop. So this says, so this is supposed to say it's not the case that n is both even and prime. And if you start with n equals 3 and you keep checking, does it happen to be the case that n is both even and prime? The answer is always going to be no. Right? Because there are no even primes greater than 3 or greater or equal than 3. So that means that mathematically, you can infer that this is an infinite loop, because mathematically, you know that no number that's greater than 2 is both even and prime. But it might not be obvious by just looking at it. Does that make sense? Here's another extremely common example of an infinite loop. So that's something that you would see often. So this is saying while n mod 2 is not equal to 1, print n. In fact, I meant equal, sorry. So n mod 2 here is always going to be equal to 1. Why? Yeah. Because n is 3. Yes. Wait. So n is 3. 3 mod 2 is always 1 because 3 is an odd number. And because I forgot to change n, or well, not forgot, I did it on purpose, n is going to keep being 3. And that means that n mod 2 is going to keep being equal to 1. So that is just going to print 3 forever. Let's just try it. Okay. Let's check what Discord is saying. Tiramisu cake. Sure. Okay. All right. Questions about infinite loop or desserts or anything? Okay. So usually an infinite loop is a bug. Usually you're not wanting to do that. It's much easier to have an infinite loop if you're using a while loop. So you would probably prefer to use a for loop if you can. But it's not always a bug. So here's an example of something that's like an infinite loop. Well, that's a different kind of an infinite loop. But think about the cursor that's blinking there. It's going to blink forever unless I do something. So in a way that is an infinite loop where, you know, somewhere inside my computer, it keeps saying, keep blinking. So that is, in fact, a common pattern. And I want to show you an example of that. In order to show you the example, I have to teach you about input. So input is a function where you give it the prompt, for example, enter a string, and it returns whatever you type in to the console until you press enter. So works like this, and it's just going to print whatever it is that you enter. So let me do that. I'm going to say enter a string, and the prompt could be anything. It doesn't matter. And then I'm going to say you entered result. So here, what do we want to say? You entered Praxis. So here there are two spaces because it always brings in a space as a separator by default. So I could remove the space here so that there is not the ugly two spaces. It's still Praxis until it's going to become physics at the end of the week. All right. So, okay. So here's something that I can do. I'll just type it in with you. You can type it in or you can copy it from the slide. So we'll have our Praxify string function. So that's just going to return, in my opinion, plus string. And now what I can do is I can just have something like a blinking cursor where I keep waiting for an input. And then if I type something in, it just gives it back to me a little bit transformed. Plus S, return S. Oh, because it's res. Okay, and I can have many opinions. Okay. It can be anything. Questions? So this is kind of like waiting for keyboard input. So this is kind of like what you see in the console all the time. Sometimes I want to break out of the infinite loop. So I can do something like this. I can say, I'm going to keep asking for opinions and keep, well, I'll stop it with the red cross and a restart Python. So I'll keep asking for opinions, but I'll stop if I enter the secret opinion. So initially, res is going to be just the empty string, something. Okay. And I'm going to keep doing it while res is not equal to stop opinion. So it's kind of like, until you learn to love Praxis. So that could be anything, and that's just going to keep asking for an opinion until I enter the secret opinion, which I'll just copy and paste here. And now we're done. Yeah. So res has to be something initially, because the first time that I compare res to stop opinion, it has to be that res is something and stop opinion is something. So stop opinion, I decided, is the thing that makes me break out of the while loop. But res, I cannot not make it anything. The first time that res is something specific is when it's the thing that's returned from input. Right. So that's kind of an important thing to say, right? It has to be something. The only other thing that I could do is I could ask for the opinion first. So I could say res equals to enter an opinion over here. And then I'll get the first opinion and I won't even do anything if res is already stop opinion. But that's not nice because I don't print Praxify str res, so I guess I would have to do that as well. And at that point, I'm repeating the code twice. So that would do the same thing, right? So I first ask for an opinion, I print Praxify str res, and I just stop if res is already equal to stop opinion. But that means that I would have replicated the same code twice, which might introduce errors, or if I want to change the code at some point, I'll have to change it to 2 points at the same time. So that's not as nice. Yeah.
Res has to have an initial value, so evolve and track, right?
Correct. So in order for me to be able to say, is res equal to stop opinion, res has to be something. Yeah. Okay, so that's different. So this is a separate function whose job it is to just transform the strings, right? So this is saying, this is just computing this kind of thing. And this is just for the sake of the example, right? So in here, what I want to do is I want to get the input from the user. So the user would type in whatever, and then I would print the Praxified version of res. Right? Other questions? All right. So that's the lather, rinse, repeat thing. So that's I found the comic. The programmer got stuck in the shower because the instructions on the shampoo bottle said lather, rinse, repeat. So I actually I mentioned it before, but if you look at like instructions on shampoo bottles, which one does occasionally, if one is interested in that kind of thing, one might notice that in fact they do not usually say lather, rinse, repeat. So this one, for example, says wet hair, massage onto scalp, rinse, repeat if desired, right? So that's like while desired, lather, rinse, okay? I was just Googling for shampoo bottle instructions. So this is a pet shampoo one. Remember to eliminate all escape routes well in advance. Once your pet is slippery wet, he or she is suddenly smarter and faster than you are. Okay. So, all right. Guaranteed satisfaction. That's some good dog shampoo right there. Okay. Let's do a non-dog shampoo related example. So here's the task. I want to compute the log base 10 of n. How many people know what log base 10 is? So I think most people, but maybe not everyone. So log base 10 of n is a k such that 10 to the power of k is equal to n. So for example, log 10 of 1000 is 3 because 10 to the power of 3 is equal to 1,000. And then log 10, 1, say 1,000,000. So this is 6, yes. So this is 6, and that's because 1,000,000 is 10 to the power of 6. Add commas here so that there's no. Yeah. Yeah. Okay. All right. So let's say that I want to compute log base 10 of n. And of course, for most numbers, it's going to be a fraction. But let's assume that the answer happens to be an integer. So my input is n, and my output is going to be log 10 of n. So for example, if n is 1,000,000, then I want to output 6. Here's an idea for how to do this. I'll just keep dividing the number by 10 until I get to the point where the result is 1. So if I start with 10,000, then I'll divide by 10 once and I'll get 1,000. I'll divide by 10 again, I'll get 100. Divide by 10 again, I'll get 10. Divide by 10 again, and I get 1. If I started with 1,000, then it would take me 3 steps to get to 1. If I started at 100,000, it would take me 5 steps. So the number of steps that I need, where each step is divided by 10, in order to get 1, is the log of the number. Or if you like, the number of zeros at the end of 1, 0, 0, 0, 0. Make sense? So, okay. So that's exactly a while loop, right? This is saying keep dividing while the number is still greater than 1. So let's do that. Oops. Let's say that n is 1,000. So I'll say while n is greater than 1, so here I'm going to use integer division. I'm assuming that I have an exact number. So I'm saying n is equal to n divided by 10. And this is just making sure that n is an integer. And the result is an integer. I'm assuming that it's an integer. So the number of steps that I would need in order to get to 1 is the log, just like we argued. So let's first make sure that that is true, and then we'll figure out what the number of steps is. So we start with n equals 1,000. And now we're saying, is n greater than 1? Yes, it is. So divide n by 10. So now n is 100. Is n greater than 1? Yes. So divide it by 10 again. Is n greater than 1? Yes. So divide it by 10 again. Now n is 1. So it's not going to step in. So what we saw here is that it took 3 steps of dividing by 10 in order to get to 1. But what we wanted is the log, right? We wanted the number of steps. Sorry, quiet down, please. Shh. Shh. 15 more minutes. So we wanted to know how many times it took us when each time we divided by 10. So the trick is we'll just have a count variable. And initially it's going to be 0. And we're going to, sorry. Quiet down, please. And what I'm going to do is every time I'm dividing n by 10, I'm also going to increment count by 1. So let's do it again. So n is right now 1,000. And count is 0. Let me print n and print count. So n is 1,000, count is 0. We go in because 1,000 is greater than 1, divide by 10, increment count by 1. So now n is 100 and count is 1. So we divided by 10 once, that's the count, and the result is now 100. Still greater than 1, so we go in again. Divide by 10, increment count by 1. So now n is 10 and count is 2. We divided by 10 twice, and now the result is 10. Again, divide by 10, increment count by 1. So now n is 1 and count is 3. We divided by 10 3 times, and n is now 1, which is not anymore greater than 1. So that means that we're done. So after the while loop, count is the number of times we needed to divide by 10 in order to get to 1. Because every time we divided by 10, we also incremented count. So count is how many times we divided by 10, and the number of times that we divided by 10 is exactly how many we needed in order to get to 1, because we kept doing it while n was greater than 1. Became 1 and we stopped. So that's it. I'll just wrap it in the function. So highlight, press tab, and I'll return count. So let's do it with n equals 1,000 again. So log 10 1,000 is 3, which indeed it is. Let's do it with 1,000,000. So 1, 2, 3. And that is 6. Why? Because we needed to divide by 10 6 times in order to get to 1. And what we did in that loop is we just counted how many times the loop ran. Is that making sense? So this is the first example where the while loop is actually doing something interesting, because we don't know ahead of time how many times the loop is going to run. That's the whole question. So we couldn't do it with a for loop, or in Python we couldn't, and like other languages you might know that's possible. But in Python, a for loop basically has a predetermined number of iterations. Here, the whole point is to figure out how many iterations you need in order to get to 1 by dividing by 10 each time. So you couldn't do it with a for loop. There's just not a construct for that in Python. But the while loop is exactly what you need, because you're saying each iteration divide by 10 and increment count by 1. So just keep track of how many times you divided by 10. Make sense? So, okay, questions about this? Okay, so I'll do maybe one more easy example, and then we'll wrap it up. Let's say that I want to know how many perfect squares there's multiple ways to do this, of course. So let's say that I want to know how many perfect squares there are that are smaller or equal than n. A perfect square is a number such that its square root is an integer. So for example, 9 is a perfect square because 3 squared is equal to 9. 10 is not a perfect square because square root of 10 is not a whole number. And I want to know how many perfect squares there are that are smaller or equal than 10. So to remind you, so perfect square number whose square root is an integer. So for example, if n is equal to 10, how many perfect squares are there that are smaller or equal than 10? It depends how you count, but let's say 0, 1, 4, 9. So let's say counting 0, that's 4. Make sense? So, okay. So I'll do it the silly way just in order to illustrate how you would do it. Let's say that I want to know if a number k is a perfect square. And the way I'm going to do it is I'm going to say for I 0, 1, 2, 3, 4, and so on up to k, if I squared is equal to k, return true. So I'm just going to try every possible number that's smaller or equal than k. And if that number squared is equal to k, then I'll return true. If none of them are equal to k, then at the end I'll return false. So that's similar to the example with the primes that we had. So I'll say for I in range, say it explicitly 0k plus 1. So I go 0, 1, 2, up to, but not including k plus 1, so k. Say if I squared is equal to k, we found our perfect square, or we found the square root. So I'll say return true. And if I tried every possible I, and it never was the case that I squared was equal to k for any of the possible candidates between 0 and k, including 0 and k, then k must not have been a perfect square. Does that make sense? Yeah. Yeah. Okay. So now what I want to do is count up how many perfect squares there are up to and including n. And again, I'm going to do it the silly way. You can think of a smarter way of doing it. But what I'm going to do is just say, so check if I equals 0, 1, 2, and so on up to n is a perfect square. If yes, increment count. So I'll start with count is equal to 0. And I'll say for j in range. So here I'm using j just because I already used I elsewhere with a different meaning. I could, of course, reuse I different function. It doesn't matter. It's a local variable. So 0 up to n, including n, because I said small equal than n. And if j is a perfect square, I'll increment count by 1. And then I'll return. Okay, so I want to contrast this with the log example. So here, at least the way that I made it, I could pre-decide how many times I want to run the iteration, how many iterations I want to run. right? So here I said, I'm just going to try every possible candidate for the square root. So I here is basically the candidate for the square root of k, right? And how many candidates? Well, I just pre-decided that my candidates for the square root of k are 0 through k, including k. So I can just run this loop k plus 1 times, and that means I can use a for loop. Similarly here, I wanted to check whether each number between 0 and n is a perfect square. And if it is, I increment the count. So I know in advance that I'll just run it n plus 1 times between 0 and n inclusive. And that's going to be it. So that means that it's a for loop. So that's in contrast to log 10, where I really needed to say, I don't know how many times this is going to run ahead of time. That's the thing that I'm trying to find out. Usually you want the for loop. There are, to be clear, smarter ways to do this. You can think about those. I'll tell you next time. Okay. All right. Long day for everyone. I'll see you Wednesday. See ya. Bye.